needs of future generations, today's buildings must be energy efficient, resilient, sustainable, create comfort for occupants, and above all, provide a safe environment for the occupants and protect the assets of the owner. Hello, my name is Mark Harris. I'm Divisional Building Technology Director of Kingspan Insulated Panels. This video introduces IPN QuadCore. IPN QuadCore is the latest insulation core technology developed by Kingspan for our range of insulated panel systems. The core is the engine which delivers the performance of the panel system. This ultimately delivers the performance of a building. IPN QuadCore delivers a range of valuable benefits compared to alternative panel systems. Firstly, there's the thermal performance. Secondly, there's the guarantees. Thirdly, there's the environmental benefits. In this video, we'll concentrate on the fire performance of IPN QuadCore panel systems. Recent high-profile fires around the world highlight the very real differences between building systems in real fire scenarios. Material choice is of critical importance in fire safety design. Only those systems that have been tested and certified correctly should be considered safe. Systems that are not tested and certified should be avoided. The hybrid nature of the IPN QuadCore delivers a range of improved fire performance which surpasses all other insulated panel systems that utilize high-performance closed-cell insulation materials. There are three major areas where IPN QuadCore panel systems deliver differentiated fire performance. Firstly, in fire test performance and third-party certification, particularly from the insurance industry perspective. Secondly, improvements in comparison to other insulation materials. And thirdly, in independently assessed real fire performance. From a fire engineering perspective, it's important to recognise that it's the entire system that needs to be considered. This is why we undertake such a comprehensive series of tests, including large-scale system tests. The breadth and depth of independent fire testing and certification on IPN QuadCore systems is unique, both in terms of reaction to fire and fire resistance performance. Let's take a closer look at some of the key performance criteria, starting with smoke emissions. FM 4882 is the FM Global Insurance Standard for smoke-sensitive occupancies. Certification is based on a number of tests, including the 16-foot parallel panel test, the ASTM E84 test, and the UBC room test. The combination of a very low smoke recording in the parallel panel test and excellent performance in the ASTM E84 test makes our IPN QuadCore panel system the only closed-cell system to achieve FM's 4882 certification requirements. That certification is for use in smoke-sensitive occupancies, which include pharmaceutical manufacturing and storage and similar high-value, high-risk situations. IPN QuadCore panel systems are also certified to LPS 1181 Part 2, the UK insurance industry standard for building systems used internally. Typical occupancies include food manufacturing and temperature-controlled storage. Again, IPN QuadCore panel systems are the only high-performance closed-cell systems certified to this standard. Now, looking at facade systems, BS 8414 Part 1 is a regulatory standard used in a number of countries, including the UK, the UAE and Australia. It assesses the performance of facade systems containing combustible materials in medium and high-rise buildings. This standard is particularly relevant following a number of high-profile facade fires involving combustible cladding materials. Kingspan benchmark IPN QuadCore panel systems perform very well in this test, contributing to regulatory compliance for medium and high-rise buildings. As well as reaction to fire testing, it's also important to assess the fire resistance in certain occupancy situations to provide property and personnel protection. EN 1364 is the European suite of tests to assess this aspect of fire. IPN QuadCore panel systems have been tested and demonstrated to achieve superior results compared to our existing EcoSafe PIR core panel systems. The enhanced stability created by the hybrid nature of the insulation core means that spans can be increased and fixings reduced in some specifications. This facilitates cost savings. A larger range of module widths is also available. In addition, IPN QuadCore based systems are the only high-performance closed-cell panel systems to be tested in conjunction with fire penetration seals according to EN 1366 Part 3. This assesses the integrity of the complete system for the protection of services such as pipes, cable trays and ducts that penetrate fire-resisting walls. It is clear that whole system testing is the best way to assess the protection around wall penetrations. This creates absolute confidence in the performance of the firewall system to protect the adjacent compartment and further minimise the risk of financial loss. We will now look at how IPN QuadCore insulation compares with other insulation materials. But first, let's go back to basics. Insulated panels comprise of internal and external metal sheets, typically steel, which have an insulation core. They can have one of a number of different core materials, including expanded polystyrene, phenolic-coated polystyrene bead, polyurethane, polyisocyanurate, which is generally referred to as PIR, phenolic, mineral fibre, or Kingspan's new hybrid core, IPN QuadCore. It is important to recognise that each core behaves differently in a fire scenario, and when used in a panel system, these differences need to be fully assessed and evaluated to ensure fire safety design. Fire testing and certification is the only reliable way to assess panel systems. However, it's vital to use a test methodology that is relevant to the actual application. To assess some of these differences, we are using the international test ISO 11925 Part 3 to compare both the core materials and the panels themselves. The first set of comparisons uses the roofer's propane torch fire source on the surface of the insulation. Look closely at the surface combustion and the smoke emissions. Points to note are the flammability of the material, particularly at the point of initial flame impingement, the extent of fire spread and the smoke emissions from the materials. It is clear that the polystyrene and polyurethane cores are highly combustible. Whilst this is not a test to measure smoke emissions, the observations give a clear picture and help illustrate why IPN QuadCore panel systems are certified to FM 4882. These video clips compare Kingspan EcoSafe with IPN QuadCore. The differences are less significant, but note the lower surface combustion and reduced smoke with IPN QuadCore. The char formation on the surface of the IPN QuadCore is particularly noteworthy, being highly localized with no evidence of fire spread. Let's look at how the metal-faced panels react in this test. This set of video clips shows the propane gas burner on the cut edge of the panel. The clips of the steel-faced panels show the rapid ignition and melting of the polystyrene, resulting in flaming droplets and the rapid fire spread between the metal facings. In contrast, the flame causes little impact on the IPN QuadCore panel system. Now let's look at the comparison between aluminium composite panels, generally referred to as ACP, and IPN QuadCore panels. These tests help address confusion about the differences between insulated panels and aluminium composite panels. Before we look at the fire tests, let's go back to basics and understand what an ACP system is. ACP forms part of a multi-layer, multi-component wall system that includes insulation and may include mastics and sealants, along with a combustible vapor control layer. ACP panels are factory manufactured, consisting of aluminium skins bonded to both faces of a core material that is generally either polyethylene, fire-retarded polyethylene, or mineral. Facade systems constructed with ACP always contain combustible content, ranging from small, potentially insignificant amount to a very high level. These clips show the difference between a polyethylene core ACP panel and an IPN QuadCore panel. It's clear that fire causes the thermoplastic core to melt, ignite and drip from the panel. It's not surprising that polyethylene core ACP panels have been linked to rapid fire spread in a number of high-profile facade fires. In contrast, the thermosetting IPN QuadCore does not melt and damage is limited to surface char formation. Perhaps the most convincing proof of the relevance of any testing and certification regime is how the materials perform in real fire situations. Case study examples include fires in high-risk occupancies such as hospitals and schools, occupancies with high fire loads, and occupancies with high insured values. In 2015, a serious fire took place at a temperature-controlled distribution warehouse when a number of refrigerated trucks caught fire. The external cladding was EcoSafe PIR panels which helped to prevent the fire entering the building. IPN QuadCore panels are expected to perform as well or better and could contribute to lower smoke damage in similar situations. In summary, the invention of IPN QuadCore takes Kingspan systems, whether for roof, wall or facade, to a completely new level of performance. In fact, this is a giant leap on the journey towards cost-effective, resilient, energy-efficient buildings that are safer in the event of fire, better for the environment and provide comfort for the building user. The value proposition is clear. That's why we confidently back the product with a unique 40-year thermal and structural performance guarantee unrivaled amongst alternative building systems.